Assalamu alaikum warahmatullahi wabarakatuh. Welcome to online class of physics. This is lecture number 39, part 1, in which we are going to cover the topic that is center of gravity. Center of gravity is the point at which the whole weight of the body appears to act. इट मीन्स दैट पूरी की पूरी जो कोई भी बॉडी होती है, कोई भी ऑब्जेक्ट होती है, उसको उसका जो है उसको जो पूरा का पूरा उसके वज़न का जो मदार है वो कोई ना कोई पॉइंट पर होता है, किसी न किसी पॉइंट पर होता है. उस पॉइंट को कहते हैं सेंटर ऑफ ग्रेविटी. दिस पॉइंट फॉर सेंटर ऑफ ग्रेविटी इज स्पेसिफिक फॉर ज्योमेट्रिकल शेप्ड ऑब्जेक्ट्स बट इट वेरी फॉर इर्रेगुलर ऑब्जेक्ट्स. ये सेंटर ऑफ ग्रेविटी जिसका हमने जिक्र किया कि जिस पर पूरी बॉडी का जो वेट है उसका इन्हिसार होता है, ये फिक्स हो सकता है किसी भी ज्योमेट्रिकल शेप ऑब्जेक्ट्स के लिए, बट फॉर इर्रेगुलर ऑब्जेक्ट्स इट इज़ नॉट फिक्स. इट वेरी विद रिस्पेक्ट टू द पोजिशन. सही. तो इसके बारे में मैं आपको मज़ीद तफसील बताऊंगी बुक से, जो कि आपकी टेक्स्ट बुक है, सिंह टेक्स्ट बुक बोर्ड, पेज नंबर 89 पे जो चार्ट है जो कि ज्योमेट्रिकल शेप ऑब्जेक्ट्स के पॉइंट ऑफ व्यू से है. पहले मैं आपको वो बताऊंगी और फिर मैं आपको इर्रेगुलर ऑब्जेक्ट्स के सेंटर ऑफ ग्रेविटी के बारे में बताऊंगी. यस, दिस इज पेज नंबर 89 एंड चार्ट टेबल नंबर 6.1 in which we are going to study about the center of gravity of some objects having regular shapes, having geometrical regular shapes. Okay, so you can see here the first one, here it is written uniform rod, and the center of gravity of this uniform rod is at the center of the rod. The second thing is circular plate. Circular plate means, circular means exact shape, exact regular shape, geometrical shape, and again the center of gravity of the circular plate lies at the center of the plate, and any square shaped object or rectangular object which is parallelogram in shape, having 4 parallelogram sides, so the center of gravity of such a body or such a shape lies at the intersection of the lines joining the midpoints of opposite sides. Okay, the intersection of the lines joining the midpoints of the opposite sides. I will demonstrate all these things to you. And for triangular plate, it is the center of gravity lies at the intersection of the medians. And any rectangular block or cube, the center of gravity of such a rectangular block or cube lies at the intersection of diagonals. And if we say about the cylinder, so again the center of gravity of a cylinder lies at the midpoint of axis. Just look at this rod. This is a rod, metallic rod, okay? And if I hold this rod from the center, so it is going to balance, just see. And if I try to hold this rod from one of the edge, either this one or either that one, so it is not balancing at all, okay? Until unless I tightly grip it, okay? And here in the center, I am not tightly gripping it, but still it is balanced. It is balanced. I am still not tightly holding it, but still it is balanced. For this rod is balanced from the center. It means the total weight, the whole weight of this rod appears at its central point. The center of the rod is the center of gravity, possesses the center of gravity, which is the point where the whole weight of this rod appears to act. Now you can see a cylinder. It's a hollow cylinder, okay? It is a hollow cylinder, but it is a cylinder, okay? And the cylindrical shape is also balanced at the center of the cylinder. If I try to balance this cylinder from this side, it is going to fall down, okay? If I try to balance the body from this edge, again it falls down. It is not balancing at all. Okay, see, just look at that point. And if I try to balance the body, this body from the center, it is balanced. You can see here it is balanced. Okay, so again we can say the center of gravity of the cylindrical body is again at the center of this cylinder. Here you can see a circular plate, and I have balanced this circular plate at the center, from the center of the circular plate. Okay, I have balanced it from the center of the circular plate. It means that the whole weight of this plate, circular plate, is lying at its center. You can see, okay. And if I try to place, try to hold the plate from this side, see, it is not balancing. So it means the center of gravity lies at the center of the circular plate. Okay, and the whole weight of the circular plate appears to act at the center of the circular plate. Here you can see a triangular paper. Okay, the purpose to show you this triangular paper is that I can show you the three sides of a triangle and three vertices of a triangle. You can see here three sides, okay, and three vertices, 1, 2 and 3 vertex. Okay, these vertices are joined together with the opposite side of a triangle with the help of a line segment. The line segment that join the opposite vertex of a triangle with the opposite side of a triangle at its midpoint is called the median. Median is a line segment that joins the vertex of the triangle to the midpoint of the opposite side of a triangle. You can see here the midpoint of this side is this one. Okay, the midpoint of this side is this one, and it is joined with the opposite vertex. Okay, and the midpoint of this side of a triangle is this one. Okay, and is joined with the opposite vertex. Okay, and the midpoint of this side of a triangle is this one, and is joined with the opposite vertex of a triangle. So when we get three medians out of these three vertices and three sides, we can get the point where the whole weight of this triangular paper appears to act. How comes? Just look at this phenomena. See, if I'm balancing the paper from this side, okay, it is balanced. But if I try to balance the paper from this side, see what had happened. Okay, and if I'm balancing the paper from this corner, see what had happened. And if I'm balancing the paper from this side, so the three corners are not able to cope up the weight of this paper. Only the central point is there from where I am balancing. Otherwise, from any other point, it is like it is falling down. Okay, it is not balanced. See, it is not balanced from any of the edge of the triangular paper or triangular plate. But this is the paper, but it is balanced from the central point. Okay, so the point where the whole weight of the body appears to act is the center of gravity, and the center of gravity of a triangular plate lies at the intersection of the medians. Okay, now I will show you the other example. The other thing, it is also the regular shape. Okay, and it is a rectangular plate or a parallelogram. Okay, it's a rectangular shape or a parallelogram, and here you can see it is the center of gravity of this rectangular plate lies at the intersection of the diagonal. Okay, diagonal is the line segment joining the opposite vertex of a rectangle or of a square. Okay, so this is the rectangle because the two opposite sides are equal in length. Okay, this one is equal to this one, and this side is equal to this one, and the diagonal is the line which is joining the opposite vertex of this parallelogram or the rectangle, and the intersection of the two diagonal is the point where the whole weight of this rectangular shape paper appears to act. Again, I will show you the demonstration. If I want to balance, I can balance the paper from this side very well, but if I want to balance the paper from this side, you can see here. Okay, just see. Okay, so it is not balancing at all. So the whole weight of the body appears to act at the center, and this is the center of gravity of this rectangular plate. Okay, and here I will show you one more example. This is again the rectangular shape paper, and the center of gravity can also be found out this rectangular plate paper or this parallelogram with the at the intersection of the lines joining the midpoint of the opposite sides. See, this side is opposite to this one. This side is, this one is opposite to this opposite side. So so the line joining the midpoint of these opposite sides, you can see here, the line joining the midpoint of the opposite sides. Okay, we get the line segments. When we get these two line segments, then the intersection of these two line segments gives you the point where the center of gravity of this rectangular plate object appears to act. The weight at which the whole weight, I must say the point at which the whole weight of this paper rectangular plate appears to act, and this is the point of center of gravity. Okay, so I think it's clear to this point. Now let's move to the other part of the lecture. Before moving to the other lecture part, that is the continuation of lecture number 39 part 1, I must tell you one thing, that since the topic center of gravity is long, in a sense that we have covered the center of gravity of regular shaped or homogeneous objects in this lecture, and we also told you, and I also told you one thing, that the center of gravity of regular shaped objects lies at the geometric center of the objects. ठीक है ना, हमने बताया आपको कि रेगुलर शेप्ड ऑब्जेक्ट्स का जो सेंटर ऑफ ग्रेविटी है वो क्या है, वो ज्योमेट्रिक सेंटर है इन रेगुलर शेप्ड ऑब्जेक्ट्स का. ठीक है ना, or we can also say the symmetrical objects. But so far the center of gravity of irregular objects is not covered in this lecture 39 part 1, but it's the continuation of the same topic, that is center of gravity of irregular shaped objects. So I must cover this topic of center of gravity of irregular shaped objects in the continuation of this lecture 39 part 1. Okay, and that's the other part of this lecture 39 part 1. Okay, 39 पार्ट 1 को हमने मज़ीद दो हिस्सों में मुकस्सिम कर दिया है, क्योंकि सेंटर ऑफ ग्रेविटी का जो टॉपिक है वो लॉन्ग है एंड इट कैन नॉट बी कवर्ड इन वन होल लेक्चर. सो दैट्स व्हाई आई हैव डिस्ट्रीब्यूटेड इन अ सेंस दैट आई हैव कवर्ड सेंटर ऑफ ग्रेविटी ऑफ द रेगुलर शेप्ड ऑब्जेक्ट्स, एंड नाउ I will cover in the other lecture, other second part of this lecture 39 part 1, I will cover the center of gravity of irregular shaped objects.